Good morning. This topic is going to be broken up into two components. We're going to talk about selection decisions themselves, and then we're going to talk about legal, more formally. We've been hinting at legal issues, but more formally, legal issues involved in industrial psychology. Wait, what does that say in the corner? Sounds good. We first did. Okay, yeah, whatever. Okay. So, brief review on what we talked about with selection. Organizations use selection batteries. Remember, we talked about not just a single test, but a series of tests. And so, don't forget that the last topic we talked about the notion of incremental change in prediction, right? The incremental change. And so, it was a powerful thing. Effective batteries successfully predict who will succeed on the job, and successful batteries cost little money. If you recall, here was one where, let's say, criterion performance, the big one in the center, that's like job performance, number of products per hour or something. And so what we might find is that a job interview predicts 10% of, remember R squared is 10%, and the assessment center predicts 25%, and the multiple work samples predict 36%. If you put that all together, that's, let me see, 36, 56, 61, 71. It's 71%. Why doesn't it say 74? Whatever. Imagine it says big R equals 0.71. And so together it equals 0.71. But because of the overlap, the amount of unique prediction of job performance is only 0.55, which is still pretty powerful. I mean, 55% of it you're predicting. But keep that notion in mind of incremental change in predictive ability. Okay? So, before we can talk about selecting candidates for jobs, we have to talk about recruiting them. Okay? Let's get them in. And clearly there's some issues here. The organization's reputation, the organizational value, location of the company. And so sometimes companies are tempted to, say, for example, set up a new factory in some small town where land is dirt cheap or where they get a wonderful tax break or something. But if you can't get workers to come to that location, there's really no point to, saving the money on the top end. And so the efficiency of a selection system, no matter how great of a selection system we talk about, if you don't recruit qualified applicants, forget it. Now, in the past, traditionally, newspaper classifieds were the answer. I still remember when I was a kid looking for jobs, those crap jobs you get in restaurants and stuff like that. And the only places you would get, you would invest in the Sunday newspaper and find them listed in there. Obviously, the internet has come into play a lot more, but campus career centers, employee referrals, these are still fair game. These are still part of it. It really does pay to network. Like in the field of psychology, if you want to get a professor job, there are very, very specific places for, like say for the example, the American Psychological Association monitor, the APA monitors classified ads. It's online. You could go there and it'll list, and it is only for faculty positions in psychology. So most job fields have some of these real specialized sources to access information. But what we find is that, in fact, going down to the second part here, that if you only use these real specialized sources like this, you're going to miss out on diverse applicants. You're only going to get a really, really narrow set. And so if your company, and most companies do, but if your company has diversity goals, you're going to be very hard pressed to meet those diversity goals if you do not, in fact, use a variety of recruiting techniques or recruiting sources. Okay? Well, one part of recruiting that's being done now, in fact, pre-recruitment or something, is cyber vetting. And that is, and we mentioned it before, but here's a word for it, that employers are using your information from the internet to make a decision about whether or not they even want to approach you to try to recruit you. So it's a pre-selection. And what's wonderful for companies, not for you, is even though it's technically illegal for them to discriminate against you based on, some behavior outside of work, right? You were dancing naked at a frat party or something, what do I know? It's got zero predictability, perhaps, on job performance, but guess what's happening is these companies are making these pre-selection decisions without you even being aware of it. So even though you may well have been discriminated against, you'll never know. Okay, it's beyond your ability to know. Okay. All right. In other words, be careful what you put on the internet. All right. So we've been talking validity and validation since the first week. I mean, this is just what we talk about. Selection should be based on valid tests, period. And so when putting together tests or even selection batteries, you really need to validate them. You have to. I mean, again, it's just you want to avoid getting lawsuits, you need to make sure that your selection device is in fact valid. So we can talk about a validation study and validity generalization very briefly here. Okay? Predictive validity, if you recall, is the ability of a test, or in this case, a selection battery, the ability of a selection battery to predict future performance. Okay? And we know that concurrent validity is the ability of a test or a selection battery to predict current performance. And so what we find is that predictive validity is much more difficult to establish because, of course, it takes a long period of time. But in order to create the predictive validity of a selection battery, you would gather what you would do is, all right, let's just say you have a new selection battery and you would like to establish the predictive validity of a new selection battery. So what you would do is you would hire a group of people using your old selection battery. But those people that you hire using the old selection battery, you also give them the items in the new selection battery. But you do not use this information from this new selection battery for the process of hiring decision. Instead, you take those employees that you hired using the old battery, then later on, you take the scores from this new battery and see if it predicts how well they're performing on the job. Okay, as you might expect, this is very difficult and takes a lot of time. And as I said, it requires you to even if you're developing a new selection battery, then you already believe that your old one sucks. And so what you're basically saying is, I'm going to take the old one that I already believe sucks and use it to hire even more people. Okay, yeah. Instead, concurrent validity, it can be done faster. You can what you can do is you can take let's say you've designed a new selection battery, and what you can do is then take this new selection battery and give it to current employees or incumbents. Give it to the current employees and have them take the selection battery and find out how well the scores on the selection battery that they take predict how well they do in fact perform on the job. Okay? Much faster, much cheaper. So as we say, concurrent validation then uses incumbents, and predictive one uses new employees and takes a lot of time. Okay. Cross-validation, on the other hand, is applying the same predictors and criteria into a different sample. So you validate your study and you either, predictive or concurrent, but you're using a very specific sample. Workers in this factory that applied between 2017 and 2018. I mean, some really tight sample. So the question is, will this validation that you've established be useful with a different sample? Okay, so validity shrinkage is this notion that if you go to a new sample, validity will decrease. Okay, and that's too bad because I mean you've established a validity and you've got it, and all of a sudden the validity goes down. It inevitably is true. Like, look at this little box on the top. Validity shrinkage occurs because the exact characteristics of the sample used in the original study or whatever are different than the characteristics in a new sample. Okay, and the more these two samples are different, the more validity shrinkage will occur. Okay, so quite a troublesome problem. Where am I? I said that, you naughty boy. I said that. Okay. Validity generalization. What you attempt to do, and it's kind of funky. I had a book at one point in time. I don't know where it went. I might still have it in my office. How to lie with statistics. You can use statistics to do a lot of things, and perhaps validity generalization is a statistical trick that is used that might or might not have, I don't know. It's a pretty complex set of statistics that makes a lot of assumptions at various stages. But you combine coefficients, etc. At each and every step in the statistical analysis, you have to make an assumption. And so each level, each time you add an assumption, you multiply the possibility of, I don't know, I just got a problem with the idea. It makes sense, though. But some argue that the whole idea of validity generalization doesn't even make sense, that you can't generalize your validity in this kind of way. Inevitably, I mean, this validity shrinkage is the very evidence. The fact that validity shrinkage does occur when you go from one sample to another tells us that the concept of validity generalization doesn't even make sense. And so some people believe in this thing called situational specificity, that tests only validate to a specific particular situation. Okay? I don't know. I mean, it has to validate somewhat. And I mean, I'm going to fall back. I'm going to pull back from the last topic and talk about general cognitive ability tests. And we said general cognitive ability tests will predict job performance, about 25% of job performance across all jobs. And so in some ways, in some ways I agree with this notion of validity generalization over situational specificity, but I can see the point of the situational specificity. I don't know. I'm torn on it. So we can tell a client that we have a new selection battery that will result in hiring successful employees, but they want more than that. They want to know which applicant, specifically which one will be. Is this new selection battery cost effective? And we're going to talk about the utility of a selection battery. And so we find that the selection battery needs to have minimal overlap, just like that beginning picture with the Venn diagram, minimal overlap between the different predictors in the selection battery. Okay? As we're going to talk about multiple cutoffs and multiple regression approaches to selection batteries. Where am I? There I am. So the multiple cutoff approach, they call it non-compensatory, which is a funky word, which is to say, it doesn't matter how awesome you are on 99 things. If you suck at one of them, you're gone. So you can't compensate. You cannot be excellent in one and get rid of, and for certain jobs, I mean, like a surgeon, for example, a surgeon had damn well better be above the cutoff on everything, okay? And so in a simple example here, we've got a multiple cutoff approach for a cardiac surgeon, so the heart surgeon. And so you see you've got 1, 2, 3, 4, 5 job candidates. Oh, Dr. Seuss, buddy. And here's what happens, is that they're going to measure their medical knowledge and their medical school grade point and their interview score and their psychomotor test, okay? And what's going to happen is that at each one, there's a minimum cutoff. For medical knowledge, it's 9. For medical school GPA, it's 7. Clearly, you're going to have subject matter experts that come in and tell you what this cutoff should be. I mean, you don't just randomly throw darts at a dartboard to come up with these cutoffs, right? You're going to have subject matter experts involved. And so take a look. If you look at the total score in the far right column, Dr. Seuss is kicking. Man, he is whoop-oo, but he will never be hired. Because even though Dr. Seuss is a perfect 10 out of 10 and medical school grade point, interview score, and psychomotor test, or she, I guess Dr. Seuss could be a she, could be. And so Dr. Seuss falls short on medical knowledge such that Dr. Seuss would never get hired. And so what we find is Dr. Seuss is out at the first step here. At the second step, everybody would be successful and pass. At the third step, everybody would be successful. At the fourth step, Dr. Carter is out, and so all of a sudden Dr. Pratt, Quinn, and Welby should all be hired, okay, based on this, unless I just misread the table, and that's possible. A multiple hurdle approach is similar to the multiple cutoff approach, except it's cheaper. It costs less money. And so what happens is they will administer predictors in a predetermined order. And only if you can cross the hurdle of one predictor will you move on to the next. And clearly these predictors are put in order in terms of how expensive they are. And this is exactly what graduate schools do, like graduate schools in psychology. They'll have multiple hurdles. So you apply for them. The first thing we're going to do is say, is your college grade point above the minimum number that I have listed in my... If yes, move to the next step. If no, you're out. It costs almost $0 for them to apply a selection procedure in this particular hurdle. Second hurdle, is your GRE score above the minimum that we are asking for? Yes or no? Okay? And so multiple hurdles is cost effective because we're going to put them in the order from cheapest to, say least expensive on the left, most expensive on the right. So check it out. We've got 6 applicants, something. And so what happens is you might have a cognitive ability test, and the cutoff is 110. And so all of a sudden you've got, only 3 applicants pass the first hurdle. You do not have to waste time or money on those other applicants. You do not have to spend the money. A personality test, etc., etc. And all of a sudden Ripken gets a job because he's the only... He or she? Why do I think Ripken's a he? I don't know. I think it's a baseball reference. Okay. Multiple regression is a little bit different than this multiple cutoff, because this multiple cutoff or multiple hurdle treats each and every aspect of the selection battery as though it's an independent element. Okay? Multiple regression approaches attempt to take each and every component of your selection battery and put it together and combine it into a single large powerful device. Okay, and so by the time you'd use multiple regression approaches, your 6 different tests in a selection battery become one selection device. Okay, and so it's a statistical analysis that's based on prediction. Many of you that have taken a stats class learned about linear regression, right? You take information about one variable and you use it to predict information about another variable. Y equals bx plus a. That's right, bx plus a in stats class. So y equals bx plus a. And so if you ever took my stats class, we had said, look, if you have 2 pieces of information, your ability to predict will be better. If you have 3 pieces of information, it'll be better. Well, it's called multiple regression, as opposed to simple linear regression, which you might have learned in a stats class. And so you see this little equation here, y equals b sub 0 plus b1 x1, blah, 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 blah. But it's really just a funky version of y equals bx plus a, right? If this first little b sub 0 had said a, all right, maybe it'd be more sensible. But it's really that y equals bx plus a, just a more complex one. And so you find here what we've got is 1, 2, 3, 4 applicants, okay? And they got scores on a work sample, scores on an assessment center, scores on an interview, okay? And what happens is a complex equation. In this case, you see what happens is, taking a look for Stokes, for example, the predicted value of y. In this case, predicted value of y equals how much job performance I predict this applicant will have, okay? And so Stokes ends up with an 11.69. Now, how do we predict 11.69? Okay, and again, I mean, you kind of pull up your memory of those funky equations from your stats class. How do you calculate A? Remember the sums of squares and blah, blah, blah. How do you calculate the B? Oh, blah, blah, right? So you remember some of that stuff. And so you see what we got here is that the constant, or the y equals bx plus a, the a portion, the constant portion is 1.043. And so you see every applicant, all 4 of them, get the exact same constant there. Okay? Then they say the regression weight for work sample is 1.548. And so you take the score on the work sample of 3, take it times that regression weight, and you notice the regression weight for the work sample is the same for all 4, but what's different is this regression weight is being multiplied by the particular score that each applicant gets. So you put these together, and as I said, I have 1, 2, 3 separate tests in my battery, but ultimately these 3 tests come together into a single new predictive device. And so based on this, Blake might not be hired, okay? If I've got 3 positions to fill and 4 applicants, Blake, you're gone, okay? You're out of luck. And so what we find is that this cutoff score, as I said, 8, well, we might have a cutoff score, say, for example, of 11. And I mean, I'll just give I'll talk more about this later, but for all, let's say, for example, the position pays $15 an hour, and so what happens is you have to look at this predicted job performance on the far right and go, well, each of these predicted units of job performance give me the factory owner $1.50. I don't know what it's worth to me, but all of a sudden, Blake, we predict that he will produce, what is that? 8 times $1.50, 12. We predict that Blake would produce $12 worth of income for my factory, whereas the salary is $15 an hour. Clearly, if I hired Blake, I'm losing money. Okay? And so you may well look at that predicted value there and think about that in terms of utility to the company. How much money does this predicted value mean to me? And when I compare that with the cost of hiring, the cost of training, the cost of salary, the cost of course, health insurance, etc. So we'll look at these predicted things and say, is the predicted value that this person will bring to my company larger than the expected expenses it will cost me to keep them? Okay? All right. Very cool. Very cool. Here's a funky one. Be careful for complex decision rules. Here's a good one. If you remember the transitive property from mathematics from 2nd grade, if A is bigger than B and B is bigger than C, then A is bigger than C, right? It's just fundamental stuff. But imagine you have a complex decision rule, and it goes like this. If the difference in intelligence between any 2 applicants is 10 or more, choose the more intelligent, is more than 10, choose a more intelligent applicant. If the difference between the applicants is equal or less than 10, choose the one with more experience. And so when I compare A to B, let's see, their difference in IQ is only 10, and so that's not the decision criteria, and instead experience, and I hire person B. So B is greater than A. Then if I compare B to C, the difference in IQ is only 10, so C is over B. So we've got a situation where C is preferred, B is in 2nd place, A is in 3rd place. But then if you got C versus A, you hire A. Wait, what? Didn't we just say C was the highest and B was the 2nd and A was the 3rd? Holy crap. Okay, so you can get this if you have decision rules that are more complicated or multi-step. You can end up with these kinds of problems. That's a neat one. Where is that? Hey, I'm way off. Where'd I go? Not there. And by the way, this particular slide, I believe I pulled this out of when I taught a course in decision making. So clearly, just another example of IO psychology is nothing but an application of the other basic disciplines. All right, so here's the funky word. I've sort of alluded to it already, but the word is utility. Utility is, for lack of a better word, value. And so what happens is that we need to look at our selection battery and say, does it provide utility? Okay? Does it provide value? How much better is this new system than the one we used to use? Okay? And that's a powerful question. So this is the question of decision accuracy. Again, some of you that have sat through my experimental or stats courses have learned this whole hits, misses, correct rejections, and false alarms, but we call them type 1 errors, type 2 errors, alpha and beta, right? Y'all remember some of that pain. Well, hits, misses, false alarms, correct rejections. This is interesting work that actually came out of World War II, out of World War II research, when they were talking about how to tell if there was a German submarine, because they had this new thing called radar, sonar, I guess it would have been. And this sonar, and your job is to, on a ship, is that a German submarine sneaking up on me, or is this just a blob? Because the sonar is not accurate. It's full of all kinds of crackly noise and stuff. And so the notion of hits, misses, correct rejections, and false alarms came up. And in our scenario here in IO psychology, a hit is an employee that we hired that is successful. Okay? We made a decision, we did it well. A false alarm is an employee that we hire, but they are not so successful. Okay? That's a false alarm. My decision criterion said yes, and it was a no. A correct rejection is an employee we did not hire that would not have been successful. Okay? And a miss is an employee we did not hire, but would have been successful. And so these four things are troublesome, because clearly what happens is that hits and correct rejections are good, false alarms and misses are bad. Okay? So keeping the thought in mind that we want to maximize hits and correct rejections and minimize false alarms and misses. Okay? There. And so we refer to something called decision accuracy, which is the proportion, Q1 and Q3. I don't like that Q. I should have used these things. Hits and then under my face. Q1 and Q3 are hits and false alarms, right? And so what we've got here is the ratio of hits over hits plus false alarms. In other words, this decision accuracy for hires is only those people that we actually hired. Of those we hired, what percentage were successful? Okay? It's a metric which can be used to measure the accuracy of your selection battery. However, we would need to do overall decision accuracy, we would need to do something which becomes much harder. And that is to say, hits plus, which one was 2? Hits plus correct rejections, the two good ones, okay, divided by all of them. And so the problem is that this becomes difficult because it's hard to identify correct rejections. How do you know the employee you did not hire would have in fact not been successful? How do you know the employee you did not hire wouldn't have been a miss? Okay, and so we find that the decision accuracy for hires is relatively easy to calculate, but the overall decision accuracy is very complicated. So a selection battery is valid to the degree that hits and correct rejections are maximized, misses and false alarms are minimized. Okay? Got it. Predictors do a better job. Got it. Look at this. And sometimes though, the cost of a false alarm might be so high. Okay, a false alarm, if you recall, is hiring somebody that is not successful. If you have a position that requires an extensive amount of training or expensive training or something of this nature, then all of a sudden mistakenly hiring a bad employee. And so you might shift your decision criterion in such a way where you might play around and say, I'm willing to accept a higher amount of misses if I reduce the number of false alarms. And it's some pretty funky, complex stuff. And again, if you've sat through my experimental or stats courses, you've had a whole lot of earfuls on this information. Well, here's a version. This is a wonderful decision accuracy graphing for a company. If you had this, you'd be awesome. You'd be in phenomenal shape. Okay, you have more hits than false alarms, just a small number of misses, huge number. You'd be in great shape. What if this was your layout? The ratio of hits, misses, false alarms, corrects, rejections, etc. are identical. If this is what your selection battery has created, then throw the selection battery out, save your money, and close your eyes and play eeny, meeny, miny, mo. Because your selection battery is doing absolutely no good for you. Okay? So helping us to understand the selectiveness, the usefulness of, we need to understand the base rate. The base rate is a percentage of current employees who are successful on the job. Okay? And what this does, in fact, it's very similar to the decision accuracy for hires. It's very, very similar. That's hits over hits plus false alarms. We're calling it successful over successful plus failing, but why wouldn't that be hits over hits plus false alarms? So the base rate is very similar here. But what this base rate is a the current situation is this effective. The current decision accuracy for hires is this, the base rate. And so if you are to design a new selection battery, you need to ensure that the new selection battery does something better than the base rate. See, the base rate is simply a starting point from which to go. The selection ratio is the number of job openings divided by the number of applicants. Okay, so if you have 20 job openings and 20 applicants for the 20 positions, the selection ratio is 1.0. Got it. If you've got 5 openings and 20 applicants for those 5 positions, the selection ratio is 0.25. Well, clearly, if the selection ratio is 1.0, don't bother using a selection battery. You're just wasting your money because you basically had to hire every single applicant. Clearly, this goes back to the recruitment question at the beginning. All right. If you have good recruitment, then you will have more applicants than positions, and you can be more and more selective. And so the smaller the selection ratio is, the more valuable a selection battery is. Because if you have 100 applicants for each one position, then you can be highly selective and use a selection battery to choose the best candidate. Okay, so a powerful thing. Selection ratio is used in universities, by the way, as a measure of selectivity. Okay, and so they will, if you've ever read the U.S. News and World Report rankings of colleges or something, they talk about the number of applicants and the number of acceptances. And it's just it's a version of the selection ratio. But it's kind of complicated because what happens is the selection ratio at the university doesn't take into account the fact that each applicant usually applies to 10 or 20 schools, right? And so it just doesn't account for that. It puts the same applicant is being added as an applicant to 20 different positions, 20 different schools. So the whole idea is wonderful, but it is faulty by definition. Cost. Yeah, cost. Why do they spend the money? And I've already alluded to it. It's just if the amount of money that I will receive in my company is larger from the use of this selection battery, I will use it. Okay, and so it's really what it comes down to: a selection battery that makes money for the company. I'm hitting the wrong button. Okay. In order to calculate the utility or usefulness of a selection process, we can use these things called the Taylor-Russell tables. And we need 3 pieces of information to get this done. The base rate, the selection ratio, and the validity of the battery. And it's really kind of, it's clearly beyond an introductory I/O course. But we see here a portion of the Taylor-Russell tables where you've got 3 components: selection ratio across the top, base rate on the side, validity coefficient in the second column. And you simply track all 3 of these pieces of information and you get a number in the middle. And this number is the percent, how would we put it? The percent improvement, something like that, for this new selection battery. And so let's say you get a new selection battery and we estimate the change in our utility. In other words, compared to the previous selection battery, my new selection battery will predict 8% improvement in the success of employees. And so now what's going to happen is you're going to look at it and say, well, how much is 8% worth? Okay? If my workers are 8% more effective than they used to be, how much more money will I make? Meanwhile, how much money will this new battery cost me to implement? Or perhaps even in other non-dollar senses, is this new selection battery going to do a better job of protecting me from lawsuits than the old one? Okay, and with that, we'll leave it there. And clearly, the next thing to discuss is legal issues in organizational psychology, which goes from here.